Hello and welcome. We have all seen the power of large language models through applications like ChatGPT, which provide amazing question answering capabilities across many domains. However, these applications are limited in a few important ways. Firstly, they are trained on data from the internet as of a cutoff date, and hence unable to answer questions using content that is either not on the public internet or past that cutoff date. Secondly, they involve sharing data with a third-party service provider or API, which can raise important privacy and security concerns. Today, I will introduce a solution accelerator that overcomes these limitations and unlocks the capability of question answering using your own corpus of documents, using open source models, and within your own Databricks environment. Imagine answering questions based on your company's knowledge base, documents, or Slack chats. Although the example I'm about to show you is related to the healthcare and life sciences industry, the technique shown here can be applied to any industry. The possibilities are limitless. We are working with several articles from medical journals on the topic of cystic fibrosis. Each article has several pages of dense text, and it would take a very long time for a human to process all of this information. In this notebook, we use LangChain to process these documents by first splitting them into manageable chunks. Then we apply a language model to create embeddings of each chunk and store them in a ChromaDB vector database. You can configure which model is used for embedding to store the semantic meaning of your text. Now that the vector database has been populated, we can build a chain using LangChain that is designed for question answering. Before I explain that, let me ask a question. To do that, simply call the function answerQuestion, and I'm going to type in the question, what are the most common symptoms of cystic fibrosis? And while that's processing, let's take a look at what's happening under the hood. The first thing that happens is my question is converted into a vector using the embedding model, and a similarity search is performed on the vector store. This returns the most relevant document fragments, which are then passed on to the language model through a prompt. In this case, we are using MosaicML's MPT7B instruct model, but you can choose another model from the drop-down. Here we see that the language model has responded with some document fragments as well as an answer. So the answer is right here. And the nice thing is we are able to see not only the document fragments, but also links to the source PDFs, which is super useful. So in summary, it is super simple to build a question answering chain that can process vast amounts of text and get the insights you need. All the code is available as part of the solution accelerator. You can customize it to fit your unique use cases by using your own corpus of documents and selecting the language model that best meets your needs. We can't wait to see what you build with it.